NASA and Blue Origin are headed for Mars this summer, and it's shaping up to be one of the most intriguing missions of the year. The American Space Agency, working hand in hand with Jeff Bezos' private spaceflight company, has confirmed that 2 satellites bound for Martian orbit will ride aboard Blue Origin's New Glenn rocket when it launches for the second time in 2025. The payload is known as Escapade, short for Escape and Plasma Acceleration and Dynamics Explorers. It's a pair of twin satellites, each about the size of a washing machine, built by Rocket Lab with scientific instruments designed by the University of California, Berkeley's Space Sciences Lab. The purpose? To study how Mars interacts with the solar wind, essentially, how the planet's atmosphere and magnetic field respond to the constant stream of charged particles coming off the Sun. To do this, the 2 probes will take simultaneous measurements from different points around Mars, providing a multi-perspective look at space weather in the Martian environment. It's a deceptively simple setup, but one with potentially big answers about what happened to the red planet's ancient atmosphere and why it vanished. This mission will also be a major milestone for Blue Origin. New Glenn is the company's first orbital-class rocket, a heavy-lift launcher and one of the most powerful boosters currently operating worldwide. The plan had originally been for Escapade to fly on New Glenn's very first launch attempt late last year, a surprising decision, since it's rare to put important science payloads on the maiden flight of an entirely new rocket design. But Escapade was looking for a low-cost ride, and Blue Origin was eager to show off its new vehicle with a high-profile mission. In the end, it didn't happen. Rocket Lab had already shipped the satellites from California to Florida, prepping them for integration. But delays in readying New Glenn for launch caused the team to miss the narrow alignment window for Mars. Instead, Blue Origin went ahead with a different demonstration in January, lofting a company-built test payload into Earth orbit. That flight was a partial success. New Glenn reached orbit cleanly, but its booster, attempting a drone ship water landing, exploded during recovery. Hardly unusual for a first try, but a reminder of how difficult it is to master reusability. Now the satellites are once again being prepped for their Florida trip, and New Glenn is set for its second launch attempt, this time with Escapade on board. The current timeline points to August or September. But if you know anything about Mars missions, you're probably asking, wait, how is this possible? Isn't there only one transfer window every 2 years? That's the typical rule of thumb. Normally, spacecraft use what's called the Hohmann transfer orbit, the most efficient path between Earth and Mars, taken when the planets are lined up just right. But here's where this mission gets interesting. Escapade doesn't need the most efficient path, because New Glenn is so massively overpowered compared to the size of its payload. Each satellite weighs only about 120 kilograms, or 250 pounds. New Glenn, by contrast, is designed to lift thousands of kilograms to lunar orbit. It doesn't even have a published Mars payload rating yet, but estimates suggest it could put around 7,000 pounds into orbit around the Moon, meaning a trip to Mars is well within its reach. Put simply, Escapade is nowhere near testing the limits of this rocket. That gives mission planners room to experiment. Instead of waiting for a perfect planetary alignment, UC Berkeley scientists devised an alternative trajectory, an intricate dance through the inner solar system. Last year, the mission director described it as a kidney bean-shaped path. The idea is to send the satellites first out to the Earth-Sun L2 Lagrange point, the same gravitational parking spot where the James Webb Space Telescope resides. From there, Escapade would loop back toward Earth, slingshot around its gravity, and then head outward toward Mars. The price of this complexity is time. Instead of arriving in just over a year, the probes won't reach Martian orbit until September 2027. But the scientists see an upside. The longer route allows for additional science opportunities along the way. As the spacecraft travel through less studied regions of Earth's magnetosphere, they can collect valuable data about the solar wind's effects on our own planet, effectively giving us a bonus science mission before they even reach Mars. Of course, there are risks. The extended cruise exposes the satellites to more radiation, increasing the chance of damage to sensitive electronics. Still, UC Berkeley researchers are confident the spacecraft are robust enough to survive the journey. And the potential payoff, new insights into the fate of Mars' atmosphere, makes the gamble worthwhile. For decades, scientists have been wrestling with a haunting mystery. Mars once looked a lot like Earth, with a thick atmosphere, warm temperatures, and flowing water across its surface. Then, at some point, that atmosphere disappeared. The planet froze, dried out, and became the barren desert world we know today. ESCAPADE's measurements of how solar wind strips away particles from Mars' upper atmosphere could finally provide the missing clues to how that transformation happened. But ESCAPADE isn't the only deep space project Blue Origin has on the horizon. The company is also preparing for a different kind of challenge: landing on the Moon. Their first Blue Moon Mark 1 lander is currently under construction, with a test mission scheduled for late 2025, likely October or November. This robotic lander is meant to pave the way for the larger Blue Moon Mark 2, the vehicle chosen to carry astronauts to the lunar surface for NASA's Artemis V mission. Mark may first be cargo only, but it will still be the largest spacecraft ever attempted for a lunar landing if it succeeds. It's slightly larger than the Apollo-era lunar module and designed to demonstrate the core technologies Blue Origin will need for crewed missions. New Glenn has already proven it can loft payloads into Earth orbit. Getting from there to lunar orbit is a manageable step. Missions have been doing it since the 1960s. But touching down softly on the Moon is another matter. Landing is notoriously difficult. Even now, most robotic lunar missions fail. Israel's Beresheet lander, India's Chandrayaan-2, Russia's Luna-25, all ended in crashes. China has been the exception, pulling off multiple successful landings, including on the far side of the Moon. For Blue Origin, just sticking the landing would be a major accomplishment. If they fail, they'll simply join the long list of companies and nations reminded of how unforgiving lunar gravity can be. But if they succeed, it will put Blue Origin in rare company, and solidify New Glenn's role as a key player in NASA's Artemis program. The push for the Moon isn't just about NASA and Blue Origin. Around the world, other nations are drawing up bold timelines of their own, and one of the most surprising players is South Korea. Though not as well known in the space race as the US, China, or Russia, South Korea has been quietly climbing the ranks. In 2024, they established their own dedicated space agency, KASA, the Korean equivalent of NASA, to coordinate research, industry, and policy. They already have their own rocket, the Nuri, developed entirely domestically. Nuri first launched in 2021, making South Korea the seventh nation on Earth capable of independently placing a satellite of at least 1 ton into orbit. With a 3-ton capacity, Nuri is a solid medium-lift launcher, but still a few steps short of being able to push payloads all the way to the Moon. To bridge that gap, South Korea hitched a ride on SpaceX's Falcon 9 in 2022, sending their first probe, Dan-Yuri, into lunar orbit. That spacecraft remains active today, giving Korea a valuable foothold in cislunar space. But their ambitions don't stop there. KASA has laid out a roadmap that's nothing short of ambitious. By 2032, they plan to land their first robotic probe on the Moon's surface. By 2040, they want to develop a larger, more capable lander, enough to establish a permanent economic base on the Moon by 2045. And not just the Moon. The same year, they're targeting Mars, with aspirations of landing a robotic probe on the Red Planet. It sounds audacious, but in context, it's not out of line with what others are aiming for. Elon Musk, for instance, claims that SpaceX could have a functioning city on Mars by the 2040s. Compared to that, Korea's goals look downright conservative. And South Korea isn't alone. Building a moon base has become the trendy mission of the 21st century. NASA's Artemis program is pushing for a lunar gateway station and surface habitats. China and Russia have floated plans for a massive nuclear-powered robotic research station. India has said it will begin constructing a lunar base by 2047. If all of these timelines hold even partially true, the Moon could become a very crowded neighborhood over the next few decades. Of course, as always, there's a big caveat: space is hard. Failures are common, setbacks are expected, and ambitious deadlines usually slip. Which brings us to another space giant that's been feeling those difficulties firsthand: SpaceX. The Starship program has had a rough year. Just last month, a routine test ended in disaster when one of the prototype orbiters erupted in a fireball, leaving behind a twisted wreck. The test stand itself was badly damaged, charred, and unusable. For most companies, that kind of setback would mean months of delays. But SpaceX operates differently. Down at Starbase in Texas, crews have already improvised a workaround. They built a temporary mount that allows them to fuel up a Starship and fire its engines in a static test without needing the damaged stand. This flexibility is classic SpaceX: fail fast, fix fast, and move forward. There's a catch, though. The main launch pad at Starbase is designed for the Super Heavy booster, not the Starship upper stage alone. But rather than waiting, The engineers came up with a clever hack. They built a massive adapter ring so the smaller vehicle can sit properly on the booster's mount. It's a rough solution, but it means engine testing can resume, and Starship development can get back on track. Elon Musk, ever the optimist, has already set a new timeline. On July 14th, he tweeted that Starship would launch again in about 3 weeks. Given the well-known phenomenon of Elon time, that probably means closer to a month or more. Still, the point is that Spacex is pushing ahead, determined to keep momentum even after a string of fiery setbacks. Despite the explosions, it's important to remember that Starship has already notched some successes. Several test flights have reached orbit, proving that the system can work, even if it hasn't stuck the landing just yet. Each attempt generates reams of data, and SpaceX's iterative approach means every failure is treated as a step toward eventual success. That relentless drive is what keeps SpaceX at the center of today's space race. Between Starship's potential to deliver massive payloads, Blue Origin's New Glenn entering service, and national programs like South Korea's CASA making bold moves, the next 2 decades promise an increasingly crowded and competitive frontier. And if you've made it this far in the video, you're clearly as fascinated by this unfolding story as we are. So here's a little fourth wall break. If you're enjoying this coverage, consider supporting the channel by becoming a member. Members get early access to our custom-built 3D renderings, sneak peeks of upcoming projects, and the occasional behind-the-scenes look at the team. Your support helps us make bigger, better videos about the future of space exploration. So buckle up. Between Mars missions, moon bases, and rockets exploding their way toward reliability, the next chapter of humanity's story in space is about to get very, very interesting.